Hello. So our second lab here in our interactive game development course, we are adding some new pieces. We're building off of what we did before with game objects and sprites and scripts, rigid bodies and collisions, keyboard and mouse input, and trails and particle systems and audio sources for sound effects. We are starting to add in the elements of aesthetics. And so particularly in this one, we want to use some keyboard input, and I want to follow the player around. Our example game that I will build up slowly a facsimile of that I've created here is a simple game with a groundhog. And this game is having a start menu. We can click on it. It fades away into the level of the game. And by moving myself on the keyboard, I can move around the screen. So I ran into a shadow, which means it started the level over. But notice how I walk, and as I do, the camera follows me around. Other things we'll get to are going to be having little dialogue boxes show up when we get close to signs, and having triggers. We're going to be building this world with a tile map and having some other pieces go on with triggers and collisions and understanding how things can interact. See, now that I'm glowing, the shadows don't affect me. Okay, but after a few seconds, they will affect me again, and I should be able to be sent back to the beginning of the level by hitting a shadow. Okay, poor little groundhog. So let's see how we can get going with this. We're going to be using, to start off, a simple groundhog icon that I found on the Noun project, and it was designed by Nicole Yip, making sure I'm giving accreditation, or not accredited, but acknowledgement to where I'm getting this resource from. Okay, so let's go back. We are starting a brand new project here in Unity. I would like to start adding in some sprites. So let's make a folder for my sprites. Inside there, let's bring in my groundhog. Okay, so groundhog is going to be placed here in the scene, just somewhere. And now I have a groundhog game object that I'm going to attach a script to. First thing I want to do is to get this groundhog moving around the screen when I use either WASD as my keys, using the arrow keys, or even a controller. There's a nice abstract way to program in Unity so you don't have to worry about exactly which one is being used. So let's create a folder for the scripts. And here I am going to create a new C# script, and this one is going to be the one that is making the player move. So player move script. Now I always forget this, so take the player move script, drag it onto the groundhog, save your scene, and now I feel okay opening up the player move script. Should get Visual Studio up and working for me. And, oh, there it is. Got to drag it over here to my right screen. And I have a script called Player Move that I can start working with. Okay, so back in Unity, a few more things to get ready. This groundhog, I want it to interact with things in the world. And so we need to give it some physics. Physics 2D, you're going to get a rigid body. And because I don't want you to fall off the screen right away, this is a top-down game, not a side game. Your gravity is going to be 0. Okay, next thing I want to do. Let's make sure you're going to collide with things. I might not use it right away, but I want to have it there so I don't forget about it later. So I have a capsule collider. And if I zoom in here on my groundhog, you should see the very faint outline of that capsule collider. It's not a perfect match. Maybe a box would be a more perfect match, but it's enough for me, and I am pretty happy with that for right now. Okay, back in my script. Let's go add in some pieces. I'm going to be talking to that rigid body. Rigid body 2D, let's call it body. And I want to make a private float horizontal to keep track of where do I want to move? What am I trying to do in the horizontal direction? Private float vertical. Okay, so another acknowledgement of where I'm getting some information in my creation. There's a great demo out here, Stuart Pixel Games, how to do 2D top-down movement in Unity C#. So there's a lot of code that you'll find similar to what I'm implementing on this website. Please go visit it and look for more details beyond what I'm doing here. So we have horizontal and we have vertical, and I need to know how fast am I moving. So I need a public float run speed. Let's say I'm moving at a speed of 5. Okay, this is good. So update is when it happens every time the screen gets updated. So your frames, your frame rate, 60 frames per second or 65, it depends on your machine speed. But this is when we're going to be getting stuff from the user. So every time the frame is updated on the screen, let's go try to set these values for horizontal and vertical. Now, these values are going to be between 1 and -1. When it is 1, the person is trying to go to the right, and when it's -1, the person is trying to go to the left. So let's go talk to input. Input had a lot of great stuff. We saw it with the mouse position. We can talk to axis, and we are going to talk to the horizontal axis here. Now, this talks to the keyboard. This talks to your arrow keys. And if you type in the left arrow and the right arrow, you will be getting back numbers -1 and +1. Otherwise, it'll give you back a 0. If you type A and D, this will give you back -1 and +1. Otherwise, you'll get back 0 for it. And so if you're using a controller with your thumbs or whatever, as you move that joystick back and forth, you will get a value between -1 and +1, which is the amount that you've moved. It makes it into a floating point number instead of an integer. And so it just makes it so you ask one question and you can answer all 3 of those pieces. Vertical, same thing for vertical. So what is going on with your input? How are they fitting together? Great. So this is nice for getting the input, but for talking to the physics, we want to be doing stuff inside fixed update. Fixed update is going to happen at an exact slice of time. It's not going to be based on the technology and the frame rate of someone having a fast machine or a slow machine. We don't want the speed that things move to speed up if somebody gets a better computer. We want it to always move the same rate. So fixed update is the way that we can do that. If we put it in update, it would be machine dependent. This is dependent on time. So what we want to be doing here is saying, hey, rigid body, change your velocity to be a new vector 2 horizontal times run speed, and then vertical times run speed. Okay, let's see what this does. We have our code. It loads them into Unity. We have our Groundhog. Let's see what happens when we play. Nothing is moving because I forgot something. Notice that there's this bitty little red text down here. There's a null pointer exception at line 30. Now, if we click on this, it should take me to line 30, and it's like, oh, there's something wrong here. What am I doing? I'm talking to body, but I forgot the critical step of saying, just declaring that I have one isn't enough. I need to go find it. Body equals get component rigid body 2D. Okay, So if I set up my name, I need to make sure I assign it to the actual reference, and now I should be able to talk to it. Good. Inadvertent mistakes are good demos of what to do and what things will go wrong when you forget things, like I do. Okay, no more red text. What happens when I type WASD? Look, my groundhog is moving around the screen. What happens when I hit the arrows? Same thing. My groundhog is moving around the screen. Okay, groundhog moves a little faster going in diagonal than it does when it goes normal up and down, because the speed is additive. And if you're saying move one to the left and one to the north, it gives you sort of a 1.14. You are going a little bit faster. The square root of 2 is your speed in that direction. And you want it to be a speed of 1 or a speed of 5 here. So let's actually go fix that. Let's add something called the move limiter. And to get rid of that square root of 2 idea, we divide it by 2, and it's like, oh, we should only be going as fast as 0.7 when we're going in a diagonal direction, and that will make sure we are going to the right space. So before we do things here, we need to ask a question. Hey, is the horizontal and vertical currently in use? Are you going in 2 directions at once? And if you're going in 2 directions at once, then horizontal times equals the move limiter. Same thing for vertical. Okay, now my speed should be consistent with my keyboard input here. Okay, I'm moving back and forth, and let's go diagonal. Looks like the same speed. Good. Okay, so what if I wanted to change the speed? Well, I'm tempted to go out here and change things in my script. I could change and say, I want to go faster. Let's go 10 times as fast. I come back here to Unity and I run things, and I am not moving 10 times as fast. Well, that's strange. If I go out here and want to go super slow, like 0.1, I go back to Unity, and I'm still going the same speed. This is something strange in Unity. I'm not really happy with it, but this is what happens. When you put a script on an object and you have declared something public, whatever number you had there first becomes the value here in your inspector. And this value of 5 is still there. As soon as you attach that script, it no longer cares what your initialized value was out here. It's just irrelevant. Because it's public, it says, I don't care what that was, I will remember whatever you have here. So if I want to make it go faster or slower, I have to start working here. Now this is great for a designer. When you create something that's public and you're going out and just letting them move things around and change things in the speed, you don't have to go to code all the time. But my brain says, go to code to change numbers. And I forget to go to the inspector when things are public. So if I actually want to make it slower, I have to change it in the inspector. And now I've got a nice slow groundhog out there instead of a fast groundhog. Okay, so that is going to be getting us some player movement. And it's a nice abstract way to do player movement. Now notice the player can wander off the screen. Next video, we want to see how we can keep the player in the frame of the camera. We're directing our game as much as we are designing and developing it. We're the director too, and so we need to think about being the director, and we're in charge of where the camera goes. and how it fits on the screen. We have a camera, we have a line here, and we're going to figure out how do we get this camera focus to be following us around in a couple different ways. Some of them are more successful than others. Okay,